All right, here we go. I figured out what we were doing wrong. So when you went to File New, there was an Advanced tab. So this was the Novice opening screen. So if you go to the Advanced tab, it'll ask you which template you want. And you see here, these are the drawing templates. So this is the standard drawing. This is the standard aerospace, the one I made. That's going to be similar to what you're making. And then you see these are the parts. That's a part little image. There's my Katy Perry. And here's an assembly that has the little part and another little green part. So you can make templates for parts, assemblies, and drawings. I just want one for a part and a drawing, and the drawing one is really the most important. But so spend the most time on the drawing one. The part one's just going to be kind of a quick do something funny just so that I can tell you did it. All right. So, but let's say I'm going to do my aerospace imperial part, and that way my units come up the way I want them, my toolbars come up the way I want them. Okay. Next thing we're going to jump into is basics in SolidWorks. So I'm going to open this little Lego quiz part I have. That's also should be on D2L if you want to look at it, but you don't need to open it right now. I want to show you that SolidWorks is, again, what's called feature-based modeling. So we start with a sketch, and then we make a feature off that sketch. So, and it's historical. So this is in order of how I did it. So if you look at the first one and open it up, you can hover over the feature. There's the feature. Okay, it's kind of hard to see, but this is a little lit up, whereas these aren't. See how that's a different color? Or a different, yeah, there it is. Different transparency. So it's looking at this feature only. And if you look at the sketch, if I click the sketch, you can actually see the sketch, the base sketch underneath this. Now, if you really want to see the sketch, you can right-click on sketch and hit Edit Sketch. You'll know that, and this is important because you start modeling, you'll start forgetting where you are. You'll know you're in a sketch if you see this little dialog here with these pictures. This is the sketch, and if you click this, you're saying, I accept the sketch as it is, now get me out of here. If you click X, you're saying, get me out of here, but don't accept any changes I've made. Okay? But here you can see my sketch was basically this rectangle. Okay? And then I dimensioned it as 2.5 and 1.25 inches. All right, I'm going to accept that sketch and go back to the part. If you go to the feature itself, you can click it, and you've got these other options. You could edit the sketch, you could edit the feature, you can suppress the feature, you can roll it back, change its appearance, you can look normal to it. So there's that look normal to that feature. I can hide that feature. So it's kind of gone. I'm going to go back and show it. I can suppress that feature. So if I suppress that feature, it's kind of gone, but it's not really gone. It's still there. I just kind of said, I don't want to deal with you right now. It's suppressed. And that becomes very useful later. I can tell you where that really becomes useful. On this unit, down here is a potentiometer, and that's a feedback mechanism for the motor controller. Well, when we originally built this about a month ago, we used a different potentiometer. It had a different size and shape. So we designed this block and all the little pieces that connect it and hold that potentiometer around that potentiometer. Then Professor Hodgkinson decided to change the potentiometer on me. So instead of deleting all that stuff, I suppressed it and then built new mounts and connectors and collars for this potentiometer. But in my CAD model, if I ever want to go back and use the original potentiometer that he wanted, all I have to do is suppress these components and unsuppress the other ones, and bam, I got a more versatile model. It's right there. I didn't delete it, I don't have to redraw it. So it's pretty useful to use this suppression feature. So I wanted to show you that. You can also edit the feature. So if I go up here and click Edit Feature, I can edit the feature. Now this is a very simple feature. I basically just took my rectangle right here, the sketch, and I extruded it up 0.375 inches. That's it. There's not much else to this feature. Other features will have other options, but that's how you go back and edit. And then this green check mark, I call it accept or OK. So you accept your changes or you cancel your changes. All right, so that's a feature. Okay, feature-based modeling. There's different types of features. So here we have, this feature was called a boss extrude, and a boss is kind of something that has thickness, as opposed to a cavity like this, which is kind of a cutout. So a boss is kind of a raised feature, and a cavity is kind of a cut feature. All right. You can have other types of features. You can have fillets. You can have chamfers. So for example, I can go in and I can take this edge and I can go to my features toolbar and pop in a fillet, and I can tell it what radius I'd like that fillet to be, and it usually gives you a preview. You can select whether you want it to preview it right here. And if I say OK and accept that, now I have a fillet, kind of a rounded edge. All right, and see, here's that fillet right here. You can see that fillet. So historically, that's where I put that fillet. You can always go back to that fillet and you can edit that feature, right-click, edit that feature, or you can delete that fillet. Okay, you can hide it, you can suppress it. So it's still there. Instead of deleting it, you can suppress it. It's still there, but it doesn't show in the model. All right. This is historical modeling, and that's important because you can do things in different, SolidWorks will react in different ways based on the way you did it, the historical way you did it. And one of the ways I explain that to students is through mathematics. You can get different answers based on the order of your operations, right? So for example, same answer, different answer, right? Because of the order I did this in. Same thing is true of SolidWorks. All right. So as an example, let me open up another part. So look here. This is the same Lego. The only difference is I have these little fillets around these posts, but I don't have to have those fillets. I could suppress that feature, and then this part should look extraordinarily similar to this part. It's the same part. But look at my history. So here I made a rectangle, and here I made, if I look at this sketch, 8 little annulus circles. And then I extruded them up. Okay? Then I did this cut extrude on the bottom with these 3 circles. And I did this cut extrude. If you look at this sketch, it's actually this rectangle. So I cut the rectangle out. And then in this boss extrude, I made these 3 little annuluses and then extruded them out. But if you go to my other Lego, which is the exact same thing, I did it in a totally different way. So I had the same rectangle. I started the same. Then I made, if I look at this sketch, I made one annulus and extruded it into this post. And then I did a linear pattern and patterned this one pink guy into these 8. So now if I make a change to this one guy, it changes all of these. As opposed to this guy, if I wanted to put a fillet on this edge, I have to put a fillet on every edge. Whereas if I go to this guy, since I patterned all of these 7 off of this one, if I put a fillet on that edge, they're all going to do that. All right? This is called design intent. So I have the exact same Lego here, but in this case, I thought about it ahead of time, and I made the part based on what I anticipated I would be doing with the part later. So I made it easier for myself to change these posts later. So maybe I wanted, as the designer, I wanted to change these posts, or I knew down the line one of my buddies in my project group was going to change this on me. I just needed to get something down on paper to start with, but he's going to change this on me later. So I wanted to make this part pretty adaptable so that my buddy systems engineer, when he comes and changes it on me 10 times, I can change it quickly. Okay? That's called design intent. If any of you have ever programmed before, you don't just walk up to C++ and just start hammering out code. So maybe some of you do, and you can do it that way. But it's better to sit down, write down your architecture, write down your subroutines. How do I want to build this program? How do I want it to operate? What routines do I want it to call? And then order and structure that program before you start writing the actual code. This is the exact same thing. You want to step back and say, all right, I'm going to make an assembly that's my bicycle. What about my bicycle do I want to change and adapt? And what's got to be hard-coded and I don't really care, it's never going to change. Okay? Design intent. So if you're doing a quick part and you just want to knock a part out, fine, just start coding it. But if you're thinking long-term and you're doing a big project, you want to sit down and set yourself an architecture before you start programming in your parts. All right. Well, I'm going to talk about that in a few more ways. But while I'm talking about that, let me show you this rollback bar. So related to this historical modeling, this bar right here is called a rollback bar. And I can roll history back in time. So you can grab that. Remember I put this fillet in? You can grab that and drag that thing back up above that fillet, and that fillet goes away. It's still there, but it went away. Now I can grab this and back one up, and you can see that I lost my boss extrude that was underneath here. If I back this up, I lose that cut extrude. Back this up again, I'm going to lose those bosses, and then I'll lose the whole part. So that rollback bar can become useful, especially when we look for errors later. You'll see that later. All right. All right. I want to show you errors, and I want to show you design intent. So I pull this up. Let's say that my systems engineer buddy in my group decided to change the length of this Lego. So I can go into the original sketch. I can edit that sketch, and let's say he made it 10 inches. And then I accept the sketch. Look what happened. Yeah, it made it 10 inches, but all my little posts stayed on the left-hand side. What if I wanted them to stay on the right-hand side? Or what if I wanted no matter how big I make it, for this thing to drop in as many posts as I want and distribute them evenly across the Lego. That's what I mean about design intent. So when you go later, a month later, and you want to make a change to this, you want the part to adapt the way you want it to adapt. All right? Why did it keep all those little Lego posts on that side? Any ideas? The reason is the sketch. In this case, I did that linear pattern based on that one post. In this case, I told this SolidWorks that the rule for this post is that it be 0.31 inches, the center of it be 0.31 inches from this edge and 0.31 inches from this edge. That's a hard and fast rule. It's not going to change no matter what I make the length of this thing. So, and then that linear pattern comes off that post. So that's always going to stay that way. Now I don't have to make it that way. I could make it such that it centers itself in that horizontal dimension. Or I could make it so that it comes off the right-hand side. And we'll talk more about that later. But that goes to design intent. How do you want it to adapt? All right, now I want to go, I was able to create rebuild errors. I'm going to go into this one and see if I can make an error, because I want to show you rebuild errors. So I'm going to do the same thing, change the length of this one to 10 inches, and it says there's errors. Okay? Now, SolidWorks tries to help you and figure out the errors. So let's take a look. So you can continue and ignore the error, or you can stop and repair. Let's say continue and ignore the error. All right? And it says, it tells me what's wrong. And it says the sketch has intersecting contours on Boss Extrude 3. All right, and I'll hit close. And then it'll make them red. It'll make your whole part red because it's not rebuilding correctly. This little stoplight thing up here is the rebuild. So it tries to rebuild the whole part based on any changes you've recently made. Your part is jacked. It's screwed up because it's red. And then it says where it's red. So Boss Extrude 3 has an error, and it says intersecting contours. Now, the problem with SolidWorks is it tries to help you out, but it's not really helping us out. Now, if you go into the sketch, you can see these 3 huge circles. Now, I had to try and kind of guess what the problem was. Let's go back. Let's close that out. Don't save. And let's open that part back up and see if you can guess. Do you see anywhere in here that I have 3 circles? Where's the 3 circles? Right here, right? So if I look at Boss Extrude 3 and I look at its sketch, there's my 3 circles. Remember when it had that error, it made those circles really big? So what could potentially be the error here? I'm going to open this sketch. Check out what I did here. See how I dimensioned this outer circle, but I did not dimension this inner circle? So when I made that thing 10 inches, SolidWorks, for some reason, I don't know why, but it blew that little circle up into a big circle. All right? So if I dimension this little circle and accept that dimension, accept that sketch, and then I try and make it bigger. So I'll edit this sketch. I'll make this 10. You see now I have no rebuild errors, and those 3 little circles stayed in the middle and no rebuild errors. All right, now I'll show you more about that later, but what I wanted to show you was that rebuild error thing. You really should stop and try and diagnose and try and think what's wrong with that thing. Don't just plow ahead, because it causes problems down the road if you have parts with rebuild errors. And on some of the grading rubrics I have for you, well, all of them, one of the points is I open the part up and there's no rebuild errors on my SolidWorks. So it better be right. Okay? Any questions on that? Sometimes it's hard to find that find those errors. Okay. Let's close that for now. Let's do a new sketch. So I'm going to go File, New, Part. I'll do Aerospace Imperial. Not doing Katy Perry. And then I want to start a part. So to start a part, you always have to start a sketch. Okay? And if you go to Sketch, there's regular sketch and 3D sketch. We'll get into that later. But right now, you just want a regular sketch. Let's pick a plane. Doesn't really matter. Let's pick top. Okay? You can see here I'm now in a sketch. In my feature tree manager, you can see sketch 1. Okay? Let's start sketching some lines. So we'll go to this line tool and we'll just start sketching some lines. I'm just going to pick some lines. Now look what's happening. There, SolidWorks does what's called snap. It'll do some snaps and you can set that in your options. It is trying right now, as I'm dragging around, it is trying to figure out what I want. It's trying to guess for me. See this little dotted line it just put in, that vertical dotted line it put in? It's trying to guess. What would you imagine it's trying to guess there? It's a good try, but what that specific vertical dotted line, what do you think it's guessing that I want? Not quite. It's guessing that I want that those 2 points be vertically oriented with respect to each other. So I'm going to go ahead and click that right there. And then maybe I'll go click this one here. All right. Now notice it wants me to draw another line. I still see the little pencil. I still have that pencil tool. If I want to get out of the line tool, I just hit escape and I'm out of the line tool. All right. Now, I want to talk to you about relations, and this is extremely important, so pay attention. In your sketches, there are things called relations. Relations are different from dimensions. All right? To find your relations, go to your sketch toolbar in your command manager, and it's right here. There's a display delete relations tab. And you can display delete relations. Now if you look at all the relations in this sketch, there's only one. There's one relation, it's coincident 0, and it shows up right here. If I click it and highlight it, you'll see it here in pink. It's coincident, point 1 is coincident at the origin of part 5, okay, point 1. So basically I had an origin here, and SolidWorks, when I drew those lines, automatically put in this coincident relation. I tell you this because this stuff can mess you up later. So you can get into trouble with these relations, and I want you to figure out how to know what the relation is and how to find it. And that's how you do it. Now I could delete this relation. See, I could suppress it. Or I could delete it. Let's delete it. Nothing really happens here other than there's no relations in the sketch. All right. Now, a relation you can kind of think as a rule. All right, that these things have to follow. If you look at this four-sided figure, there's no rules that this has to follow. It's underdefined. Underdefined sketches are blue in color. Okay? If they're fully defined, they're black in color. And if they've got problems, they'll either be red or yellow in color. All right, we'll see that later. But this is completely underdefined, which means I can move it around. So I can grab this line and I can drag it around. I can grab this point and I can drag it around. Okay? I can do all kinds of dragging and dropping and stuff. All right? Now, if I want to define it, one way to define it is to add some relations. What if, so go to this display delete relations, and what if I hit add relation? What if I want this line and this line to be parallel? Always for all time. Okay, so you can see here in this dialog, I've selected the two lines and I want them to be parallel, so I click that. And then I hit the check mark to accept it. Now look at this. It shows the relation parallel, parallel. All right? And if I hit display delete relations, I see a parallel relation. Now if I try and drag this thing around, look what happens. I can drag this point around, but look what happens to those lines. They're always parallel. All right, let's put another rule in. Let's say I want to add a relation. Let's say I don't want to add a relation. I'm going to put a different type of rule in. I'm going to put a dimension in. So I'm going to go to Smart Dimension. Now if you drop this box down, you see there's all different kinds of dimensions. If you just select Smart Dimension, it tries to guess what you want. So like if I grab this line and I drag away, it could do the length of that line. If I pull to the left, it could do the distance vertically between those 2 points. Or maybe it would do the distance horizontally between those 2 points. So it tries to guess, which works sometimes and doesn't others. So be careful, watch when you're dragging things, what you're doing. I'm going to dimension just the length of that line, and I'm going to make it, say, 2 inches, and accept it. Okay, now I've made that a rule. So that line cannot ever change from 2 inches, and these two lines cannot ever change from being parallel. Now go around and try and drag some stuff around. Check out how this works. Getting jiggy with it. No. Okay, but look, those two lines are always parallel, and that line there is always 2 inches. So if I try and drag his little vertex, I can drag that vertex, but he's always 2 inches, and the other two are parallel. Make sense? I can notice I'm still not fully defined anywhere. I'm all blue. And that's because I can drag things around. If I add one more rule, I bet this thing's going to start turning black. So let's add another rule. Let's add a relation and say, how about this point? I want it to be fixed in space, so it cannot move. Fix. Okay, I'm still underdefined. Check this out. That point cannot move. It's fixed in space, but I can still make a variety of shapes that have one edge that's 2 inches long and two sides that are parallel. All right, let's add another rule. Add a relation. You know what? I'm going to add a dimension rule. Let's go Smart Dimension, and I'm going to add a rule that says between these two, all I did was select these two legs, and it guessed that I want to put an angle in there. So let's put an angle in there. I'll say 75 degrees. Okay, I accept that. Holy cow, I'm still blue everywhere. All right, I can still make a variety of shapes with that rule. All right, one more rule. I can feel it. I can feel it. We're gonna get this dimensioned. Let's add a relation that says that these two legs have to be perpendicular. Are you kidding me? I'm still underdefined. So if you look at that, I can drag around, but look at my degrees of freedom. Look how much they've closed. See that degree of freedom? I pretty much only have one, it looks like. Right? Or maybe I have, I have this degree of freedom as well. So I'll bet you, since I have this degree of freedom, if I restrict the length of this line, I won't have that degree of freedom anymore. So I'm going to hit Smart Dimension, click that length, make it 7 inches. Oh, come on. I still have too many degrees of freedom. All right, I'm going to go ahead and let's add a relation that makes this line vertical. Now look what just happened. Every single line in there turned black. I am fully defined. I have no more degrees of freedom. I cannot drag this thing around. I put so many rules in here that this sucker can't change. Okay? Now if you did want to change something, you'd have to start deleting rules. All right? And remember, dimensions are rules and relations are rules. All right? Now, watch this. Let's say I want to, this is fully defined. I cannot define this any further. Let's say I want to add another dimension, say to this side, and I click it. Everything turned yellow. And that means it's got a conflict. All right? SOLIDWORKS is going to ask me, do you want to make this dimension driven, which means it's driven by all the other rules? Or do you want to leave this dimension driving? So you're going to force this dimension. But you can't force this dimension to be something else and still jive with all the other rules. So let's do it. Let's say, leave this dimension driving. Let's do something we can't do. And it's going to say, item is unsolvable, item conflicts. Now I'm over-defined. See that in the bottom? I'm over-defined because I dimensioned this. All right, and everything turned yellow. So to fix that, I can kill that dimension, delete it, and now the sketch is no longer over-defined. So I wanted you to see that, so you understood that. Okay, questions there? This is really important because when you start building your parts, you're going to start having errors, and you need to know where to go look and troubleshoot and diagnose the errors. Okay. I want to show you a couple other things. Let's go ahead and finish this sketch. So we'll accept this sketch. Okay. And then let's make a feature out of it. So you just go to Features, Extruded Boss Base, and we're going to extrude it maybe 1 inch. It does a preview. I can go units inch. I can change the direction. Look at this. So I can see this little arrow. I can reverse the direction, and then it went the other direction, or I can make it go up. That's useful. I can select, I did blind, but in other circumstances, maybe I want it to go all the way up to another part that I've already made, up to another surface. Okay, we'll play with that later. But let's just accept that. I want to show you some different display states. So if you remember your heads up bar, you can drop this menu down and look at different sides of this thing. I can go left, I can go front, I can use my roller wheel to kind of twist this around by pushing it down. I can select this face and I can say I want to be normal to that face, and then I'm looking at that face. So moving this stuff around is kind of useful. I can change its transparency. I should be able to change its transparency. Okay, I wanted to show you this. So there's this little double arrow thing in your feature manager. If you click that, it shows your display pane, and it'll show you the display states of every item you have. So in this case, we only have one feature, which is this Boss Extrude. It'll show you the color and the transparency and the display mode and whether it's hidden or shown. Now that doesn't seem very useful there, but if I open this model of your final SolidCAM project, let me open this guy up. This might take a second to open up because it's a big assembly. But it becomes very useful when you have big assemblies, because if you want to find a part that's hidden, sometimes you can't find it in this big nasty list of parts. If you look at the display states, all you have to do is look at the ones that are hidden and you can find it fairly quickly. Let it open and I'll show you. If you notice, while this is opening, a couple of the pieces of this model are transparent. They're kind of see-through, and other parts aren't. So if I want to find those pieces in my design tree quickly, I can use this display pane to find them by just looking at the ones that are transparent. So hopefully this comes up in a minute. All right. And then I'm going to say one last thing about design intent, and we're done for the day. We'll continue that design intent discussion tomorrow. While this is opening, let's go over the homework. You can always find it on D2L under the course documents, under the calendar. Your homework tonight is to watch the tape measure, calipers, and micrometer measurement videos on YouTube under the playlist Machine Shop. You also need to do the SolidWorks tutorial, which is under this resources toolbar. And you need to make your own drawing and part templates and upload them to D2L under Dropbox under Homework 1. Is there any questions about that? So you're graded on all that stuff. Okay? All right, this came up. Now look, if you look at how many parts are in this assembly. Look at all that stuff. Okay? If I just want to find something quickly, I can look at my display states and I can find parts that are transparent. See? There's only a few of them. So this little bar is pretty useful, and most people don't know about it because it's just these two little silly arrows. But it's useful sometimes. You can also go to something. So look at this thing. Look what it highlighted. This is one of these pillars, and it's transparent. You can go to that and just quickly hit that transparency, and now he's not transparent anymore. Okay? And then you can change colors of components. So you can go to a component and change its color or its texture or any of that jazz. All right. Enough of that. We're going to do a new part. Let's do a new part. And I want to talk about design intent again. So quickly, I want you to do this with me or without me. I want you to sketch me a rectangle that is, and it's a rectangle that's 3 inches by 1 inch. So sketch, pick a plane. You can use the rectangle tool, and then you can pull 2 points. Escape out of that tool. Notice when I drew it, 2 of those lines are black. Any idea why 2 of the lines are black using the rectangle tool? Two of these lines are black. It's hard to see this one because it's orange. There. Two of them are black, two of them are blue.
They have to be at 90 degrees.
That's right. So a rectangle, by definition, has to have two sets of parallel sides, and those sets of parallel sides have to be perpendicular to each other. How would you know that? Go to your display delete relations, and SolidWorks forced these two sides to be what it calls horizontal. So that's parallel. These two sides to be vertical. And then I picked coincident at the origin. So that forces that point to be in that place, which forces some of these sides to be black. Now let's dimension it. What did I tell you? 3 by 1. And now it's fully defined. Go ahead and extrude it and make it a 1/2 inch thick. Under features, a 1/2 inch thick. Now I've got a rectangular bar. We all there yet? Okay, now let's say I wanted to cut a hole through that thing. All right, and we're going to run out of time here, but I'm going to set you up for tomorrow. So just for a second, watch this if you're not there. If I wanted to cut a hole through this thing, first thing I need to do is pick a face that I'm going to cut a hole through, and I need to make a new sketch. I need to make a new sketch on that face. So see how it says sketch 2? All right. I'm going to draw a circle to make a hole. Okay, I dimension the radius, let's say 0.25 inches. Now I've got a circle. I'm going to get out of the sketch, and this time I'm under my features. I'm going to say extruded cut. And notice I'm still highlighted on the sketch, so I'm going to cut based on that sketch, which is a circle. Extruded cut. And instead of being blind, I want to go through all. I want it to go through the whole piece. I accept that, and there's my hole. See that? Now, for tomorrow, what we're going to do is if I go to this hole and I want it to be centered, I could hit a dimension from this side to the center of the circle. Remember, my bar was, what was it, 3 inches thick, wide? So centered would be 1.5, right? And then what if I do a dimension here? My bar was 1 inch wide, so if I made it a 1/2 inch, it would be centered, right? And I escape my sketch, so I'm centered, right? What if I go to my original sketch of my big rectangle, and instead of making it 3 inches, I make it 7 inches? Will that hole stay centered? No. And maybe that's my intent. Maybe I don't want it to stay centered. But what if, as the designer, I did want it to stay centered? No matter how many changes I make to this rectangle, what if I wanted it to stay centered? What if that was my design intent? Okay? That's what we're going to start off with tomorrow. Any other questions about what we talked about today, or about the class structure, or anything in general? Does everybody know what they're expected to do for homework by tomorrow? See ya. Have a good day.